So what we're going to do now is we're going to actually walk through the source code for StructuredTaskScope. And we're going to start out by talking about the parent class called StructuredTaskScope. And you'll look at that, and then we're going to take a look at the two subclasses provided out of the box, which are nested inside of StructuredTaskScope, which are going to be ShutdownOnSuccess and ShutdownOnFailure. You can get all of this code here from this GitHub repository, which contains all the source code for the Java OpenJDK variant. And this particular version we're going to look at is version 21. So here we are in the version 21 source code of Java. And if you take a look down here, we can see that we have the StructuredTaskScope. That's this file right here. This is a little menu item that you can get with IntelliJ that will let you zip around here very quickly and find different parts of this, like different nested subclasses and methods and so on. So this is the StructuredTaskScope class. You can see that it implements AutoCloseable. What that means is when you use this in the context of a try of the resources block, when that block is exited, the close method will automatically be called, which is defined in AutoCloseable. And we'll see it's going to shut everything down and make sure all the threads have gone away. This code has been reformatted a bit by me to make it a little easier to explain. I've also added a bunch more comments. Sadly, a lot of the Java source code, even though it's open source, is not well commented. Once again, ChatGPT to the rescue. ChatGPT does a very nice job of documenting code, so I added a bunch of comments here that makes it a bit more intuitive to understand. There's a field called a ThreadFactory that can be used to determine whether we create a virtual thread or a platform thread, or what kind of threads we make and what parameters we pass to them. There's also an internal class called a ThreadFlock. Once again, good luck finding any documentation on this, because there isn't any, but ChatGPT was good at explaining it. And this basically is used to coordinate a group or a flock of threads within a try with resources block, and we'll see where that gets used. There's also a rantrant lock, which is a synchronizer that's used to protect certain parts of this code from race conditions, especially having to do with shutting things down. Then there's a bunch of enums, which define the states of a structured task scope, and that includes when it opens, by default it opens, by default it starts in the open state, and then if you shut it down, it goes to the shutdown state, and then when it's finally finished, it goes to the close state. And they intentionally design these to be basically a sequence, 0, 1, and 2, and you'll see where that gets used in the code below. So let's go ahead and take a look at the constructors for this class. You can see there are two constructors. One constructor takes a ThreadFactory, and that will then take that ThreadFactory and stash it away. And that ThreadFactory will be used to create the appropriate kind of thread. That allows the user to dictate what kind of thread to create. A platform thread, a virtual thread, and the user can also define other things like the name and so on. If you don't use the ThreadFactory, then by default, StructuredTaskScope defaults to using a virtual thread factory. So thread of virtual factory. So that's what you get by default if you don't do anything else. Down here is the main entry point method into StructuredTaskScope. This is fork. We've seen how fork gets used. What fork does is it takes a callable, which is a task of some type U, and it will arrange to run it using whatever threading mechanism we've defined, be it a virtual thread or a platform thread or whatever. And it's going to return something called a subtask. This is different from earlier versions of Java where they returned futures. I like the subtask version better. So let's take a look at what really goes on here. So the first thing that happens, or well, not the first thing, but one of the first things that happens is a variable that's an instance of subtaskImpl is created. And this is going to pass in the task. Remember, the task is what's passed in as the parameter here. So we're going to take the task, which is the callable the user wants to run in some threading context. We're going to make a subtaskImpl. Let's go look at subtaskImpl. So here is subtaskImpl. SubtaskImpl implements subtask and runnable. So what's a subtask? This is a subtask. A subtask is a sealed interface. What is a sealed interface? That's a newer feature that's been added to Java that allows developers to restrict who can implement or subclass something. And you can see here the subtask is sealed. It's going to extend the supplier interface, but it's only going to permit subtaskImpl to implement it. So there's only one implementation possible, which is SubtaskImpl. And you can see it's got a bunch of methods defined here, such as returning the task. There's a set of basically states, unavailable, success, and failed. There's a method that returns that state. There's a method that returns the result of the task if it succeeded. And if things failed, you can also have a helper method to return the exception. So that's what a subtask is. SubtaskImpl implements that interface plus the runnable interface, which means it can be passed to a thread and run. Now, I added a bunch of comments from ChatGPT explaining what these fields do. There's some stuff that handles errors, which we're going to skip. There's a scope, which is really what context this is coming from. Here's a field that's the task that's being run. There's the round and the result. The most important methods here are really task and result. So here's the constructor, just assigns the fields. Here's the run method. So we're going to see in a second that this instance of StructuredTaskScope, that's the thing that we had up here that we were using in fork, this instance that we have here. When that is created, it's going to end up being given to a new thread created by the ThreadFactory. And then we're going to start that thread. And when that thread is started, it's going to call the run hook method. So here is the run hook method. So the run hook method is what gets called when this thing's running in a new execution context. And again, I added some comments from ChatGPT. The main thing to notice here is it's going to take the task that was passed in and stashed away by the constructor, and it's going to call it, getting the result back. Now, if an exception is thrown, we're going to capture the exception. Otherwise, we just get the result back. So at this point, we have to decide what to do. So if we've been shut down for some reason, we just return. Otherwise, what we're going to do is we're going to update the result field. And we do that in several ways. If there was no exception, then the result is basically going to be what we got back by calling the task, unless it's null. But in that case, we get a null result. But let's say we get the result back that gets stashed away here. Otherwise, if there was an exception, we do this little exception encapsulation feature with this record called alt_result. Don't worry too much about that. And then the last thing we do, and this is really important when we talk about the subclasses like ShutdownOnSuccess and ShutdownOnFailure, the handle complete hook method is called back. And we'll see where that shows up later. This is very important because it gives you, or the implementation of the subclasses, a chance to decide what to do when some computation has finished running. So that's SubtaskImpl. So let's pop back up here, and we'll go back to fork. So I just showed you what SubtaskImpl does when we associate it with a new thread, and we start that thread. So now the thread is up and running, and its run hook method is going to be called, and we return the subtask from the fork method. So at this point, things are off and running in their scope. Now, the next thing I'm going to mention, and I'm just going to show you this here for completeness. We're going to look at this when we get to the subclasses later for ShutdownOnSuccess and ShutdownOnFailure. This is the handle complete method, and that takes the subtask. Now, the default implementation here basically just does a little sanity checking and throws an exception. This method should never really be called because a subclass should override this method. This is just here for completeness. We'll take a look at the subclasses later and see how this gets used. It's really cool. Here's the join method. Remember, after you fork a bunch of things in a structured task scope in the try with the resources block, at that point, you typically call join after you've forked a bunch of stuff. And you can see what join does is it calls impl join, and impl join does a few little sanity checks, and then it calls this method here. This is very important. This is the flock for ThreadFlock await all method. And you can either do it with a timeout, or you can do it with a non-timeout, because you can decide how long you're going to wait. Let's say we do the non-timeout version. This is then going to wait for all those threads to finish. So join doesn't return until everybody has either finished successfully or been shut down on account of failure, or in the case of shut down on success because we got a result. Here's the close method. The close method is what gets called down, or gets called back when the scope is left, when the try with resources scope is left. And you can see basically what it does is it does some sanity checking, and then depending on the context, it calls impl shutdown. And impl shutdown is going to acquire the lock for this particular object to avoid problems with race conditions. And then, depending on what state we're in, we're going to go ahead and shut down the flock. And that will cause all those threads running in that flock of threads to be shut down. So we prevent new threads from starting, and we interrupt all the unfinished threads, which should wake them up, and they'll go away. So that's what close and impl shutdown does. And then there's just a bunch of other helper methods here that do various things we don't really have to worry about too much. But I wanted you to get a good sense of how this was designed. And let's see if there's anything else that's worth looking at here in structured task scope. And you can see the shutdown method also will shut everything down and make things go away. Here's how you convert this whole thing into a string. If you want to convert the structured task scope and its state into a string, you can call this method. It grabs the name of the flock, and then it sets the state of things, and it'll return you a string with that. So that's structured task scope. It's actually quite interesting, because if you go back and watch this video from last year, when I was talking about Java 19 and Java 20, we covered the implementation of structured task scope that used futures, which was actually somewhat more complicated in some ways than this version, because we had to talk about all the future stuff. But this is a nice, clean and lean way of doing things, and will give you a perspective on how stuff works at the top level. We're now going to talk about two common subclasses.